2.0.0 Installing Conductors and Conduit Systems. Explain how to install conductors in a conduit system. Describe how to install conductors using fish tape. Describe how to install conductors using pulling equipment. And you might have a performance task. Your instructor might want you to pull conductors into a raceway. 2.1.0 Fish tape. Fish tape can be made of flexible steel, fiberglass, or nylon. It's available in coils of 25 to 240 feet. Fish tape is rolled up and stored in a round plastic casing or reel to avoid twisting and damage. A fish tape has a hook or loop on one end to attach to the conductors to be pulled. So this is a fish tape. It's usually 1/8 of an inch thick and it's spring steel, and that spring steel is coiled up inside of this housing. You can hold the handle in one hand and pull the tape with your other hand to extend it. When it comes time to reel it back in, you'd hold the handle with one hand, and with the other hand you'd grab this casing and you would twist it in this motion clockwise, and as you do, it'll draw this fish tape back in. Warning: to prevent electrical shock, do not use conductive or metallic fish tape near or in a live circuit. Do not use broken or damaged fish tapes. To use a fish tape, follow these steps. Reel the fish tape by pulling the tape out of the reel. Tape up the hook loop at the end of the fish tape. Feed the fish tape hook or eyelet end first through the conduit. Fish tape usually enters at one outlet or junction box and is fed through to another outlet or junction box. So here they're pushing it through the conduit all the way to the other end, and then it comes out. You'll hook your wires on, and then as you pull the tape back out of the conduit, you'll pull those wires into the conduit. When the tape comes out of the other end, remove the tape from the hook or loop and attach the conductors you need to pull through the conduit. Once the conductors are attached, reel the fish tape back in, pulling the conductors along with it. Sometimes the fish tape can get hung up in very long conduit runs. These situations call for a rigid fishing tool known as a rodder. Rodders are available in various sizes and lengths up to 1,000 feet. A typical rodder is shown in figure 23. Here's figure 23. So we're saying you can use this to get a fish tape that's stuck in a conduit. Power conduit fishing systems. You can install string lines using a power system instead of using a manual fish tape. A typical power system like the one shown in figure 24 is similar to an industrial vacuum cleaner. It uses a vacuum suction to pull or push a string or rope attached to a piston-like plug, sometimes called a mouse. And here it says mouse is a cylinder of foam rubber that fits inside the conduit and is then propelled by compressed air or vacuumed through the conduit run, pulling a line or tape. The string is lighter than the fish tape and is similar to kite string or poly twine. So here's a vacuum system that you can use, and this end is good for fitting over the conduit if it's small size. If they're larger, you can use this one. This one actually gives you somewhere that you can put the string in, so you can use the hose on the other side where it blows out instead of sucking in. And you can have the twine going through this elbow and blow it through the conduit. These are the different types or sizes of mice. They fit different sizes of pipe. To use a vacuum power system, follow these steps. Tie a pull string or rope to the mouse. Use the vacuum to move the mouse through the conduit. In some cases, the vacuum connection can be reversed to push the mouse through the conduit instead of pulling it. Once the string emerges at the opposite end, either the conductor or a pull rope is attached to the pull string. Once the conductors or pull rope is attached, pull the pull string or rope. This is highlighted. It says in most cases, all required conductors are pulled at one time. So you need to know how many wires you need in that conduit and spool them all up, put them on the fish tape, and pull them through all at the same time. A wire grip is used to attach a cable pull to the tape. One type of wire grip used is a basket grip. A basket grip is a steel mesh basket that slips over the end of the larger wire or cable. The pull tape or rope attaches onto the end of the pulling force, and the pulling force tightens the basket over the conductor. So here's an example of that pulling basket. You put your cables in, and this will grip tighter. The more you pull it, the tighter it will get. 2.1.2 feeding conductors into conduit. After the fish tape or pull line is attached to the conductors, it must be pulled back through the conduit. As the fish tape is pulled, the attached conductors must be properly fed into the conduit. Usually more than one conductor is fed into the conduit during a wire pull. It's important to keep the conductors straight and parallel and free from kinks, bends, and crossovers. This is highlighted. It says, conductors that are allowed to cross each other will form a bulge and make pulling difficult. This could also damage the conductors. This fish tape section says metal fish tapes generally come in longer lengths and is the type used most often. Nylon fish tape generally comes in shorter lengths and is more flexible than metal fish tape. Nylon is non-conductive, so it can be used around live circuits. Straightening a bent fish tape. To straighten a bent fish tape, drive 5 16-penny nails into a 2x4 about an inch apart in a straight line. Then wind the fish tape through the nails in a slalom fashion and pull it through. This will straighten the tape. Kinked metal fish tape may crack and fail. Do not kink metal fish tapes. Spools and rolls of conductors must be set up so that they will unwind easily without kinks and bends. When several conductors must be fed into the conduit at the same time, a reel cart is used. The reel cart will allow the spools to turn freely and help prevent the wires from tangling. So here's a reel cart. So they've got all these different sizes of wire or different colors of wire and cables, and they'll pull in what they need into the conductor, into the conduit. The hook on a fish tape can be replaced using a propane torch. Always work in an appropriate environment and wear the necessary protective equipment. Hold the fish tape securely in a pair of pliers. Heat the end of the propane torch until it softens, then use a second set of pliers to form the hook in the fish tape. Allow it to air cool. Pull lines, 2.1.3. For a difficult pull, you should use a pull line instead of a fish tape. A pull is made more difficult by bends in the conduit, the size of the conductors, the length of the pull. Warning: when using pull lines, exercise extreme caution and never stand in a direct line with the pulling rope. If the rope breaks, the line will whip back with great force. This can result in serious injury or death. A pull line is usually made of nylon or some other synthetic fiber. It is made with a factory spliced eye for easy connection to fish tape or conductors. 2.1.4 Safety Precautions. The following are several important safety precautions that will help reduce the chance of being injured while pulling cable. To avoid electrical shock, never use fish tapes near a live circuit. Read and understand both the operating and safety instructions for the pull system before pulling cable. When moving reels of cable, use mechanical lifts for larger spools. For smaller spools, avoid back strain by using your legs to lift rather than your back. And ask for help with heavy loads. Also, when manually pulling wire, spread your legs to maintain your balance and do not overreach. Be careful to avoid any pinch points in the capstan and sheaves. The capstan is the barrel part of an automatic puller. This is the turning drum of the cable puller on which the rope is wrapped and pulled. Select a rope that has pulling load rating greater than the estimated force required for the pull. Use only low stretch rope such as multiplex or double braided polyester for cable pulling. High stretch ropes store enough energy, much like a stretched rubber band. If there's a failure of the rope pulling grip, conductors, or any other component in the pulling system, this potential energy will suddenly be unleashed. The whipping action of a rope can cause considerable damage, serious injury, and even death. Inspect the rope thoroughly before each use. Make sure that there are no cuts or frays in the rope. Remember, the rope is only as strong as its weakest point. When designing the pool, keep the rope confined in conduit wherever possible. If the rope breaks or excuse me, when the design pool, keep the rope confined in the conduit wherever possible. If the rope breaks or any other part of the pooling system fails, releasing the stored energy in the rope, the confinement in the conduit will work against the whipping action of the rope by playing out much of this energy within the conduit. Do not stand in a direct line with the pulling rope. Some equipment is designed so that you may stand to one side for safety. When pulling, keep the pulled rope out of the way and do not step in the loops of the rope. If the pull reverses direction, you may get tangled in the rope and injured. Wrap up the pulling rope after use to prevent others from tripping over it. Pulling equipment. There are many other types of pulling equipment available to help pull conductors through conduit. Some are manually operated and some are power operated. A manually operated puller is used mainly for smaller pulling jobs where hand pulling is not possible or practical. It's also used in many locations where hand pulling would put an unnecessary strain on the conductors because of the angle of the pull. There are also wire pullers that attach to cordless drills. They're good for small pulls in light, tight spaces such as junction boxes. So here's a small manual wire puller that you can put a drill motor in, and it's got a turns ratio so that the speed of the drill is reduced to a slow action. And you can wrap this. This is the capstan. You can wrap the pulling rope around this, and it'll just pull it at a nice slow pace. Here's a larger manual pull system. Or this one's a power puller. Here's the capstan. It's bigger. It has an electric motor. You plug it in, and then you operate it with the controls. Here we can see someone pulling a string in using the manual puller with the drill motor and wrapping the string around the capstan. Electrical or hydraulic power pullers are used where long runs, several bends, or larger construction are involved. The main parts of a power puller are the electric motor, the chain or sprocket drive, the capstan, the sheaves, and the pull line. The pull line is routed over the sheaves to ensure a straight pull. The pull line is wrapped around the capstan 2 or 3 times to provide a good grip on the capstan. The capstan is driven by the electric motor and does the actual pulling. The pull line is pulled by hand at the same speed at which the capstan is pulling. This eliminates the need for a large spool on the puller to wind the pull line. Ideally, the pull will be completed in a single smooth, steady operation and only stopped when complete, or if there's any doubt about the safety of continuing. Random stops during a pull can cause the conductor to get stuck and make pulling very difficult. Attachments to power pullers, such as special applications, sheaves, and extensions, are available for most pulling jobs. Follow the manufacturer's instructions for setup and operation of the puller. Before using power pullers, a qualified person must verify the amount of pull or tension that will be exerted on the conductors being pulled. Putting it all together. Think about the design of conductor installations. How does the location of pull points affect the ease of pulling? 2.2.1 Conductor Lubrication. Conductors may not move freely through long runs of conduit or conduit with several bends. In those cases, both the conduit and wires are lubricated with a compound designed for wire lubrication. Caution: store all aerosol fueled cable lube in a fire-rated cabinet. These compounds are available in dry powder, paste, or gel form. The compounds must be non-corrosive to the insulation material of the conductors and to the conduit itself. You apply the compounds to the conductors as they are fed into the conduit. They may be applied by hand or using a battery-operated pump. Conductor termination. The amount of free conductor at each junction or outlet box must meet National Electrical Code specification. For example, there must be sufficient free conductor so that bends or terminations inside the box, cabinet, or enclosure may be made to a radius as specified in the NEC. There must be a minimum of 6 inches of free conductor made to wiring devices or 4 splices per NEC section 300.14. Length of free conductor at outlets, junctions, and switch points, NEC section 300.14. Where conductors pass through junction boxes or pull boxes, enough slack should be provided for splices later. When a box is used as a pull box, the conductors are not necessarily spliced. They may enter the pull box through one conduit and exit via another conduit run. The purpose of a pull box is to make it easier to pull conductors on long runs. A junction box, however, is not only used to facilitate pulling conductors through a raceway system, but it also provides an enclosure for splices in the conductors. Here's section 2 review. As always, I'll let you go ahead and answer these yourself. It says, which of the following is true when pulling conductors? Then you can choose the best answer. Large conductors are likely to require the use of what? Okay. Well, this concludes 26109, conductors and cables. And I hope you got something out of the video. If you did, think about giving me a like and consider subscribing to my channel. And as always, I'll see you on the next video. Thanks. Hey, this is Brian Young. If you liked my video, please give it a thumbs up and consider subscribing. I'll see you on the next video.